Lesson 5-3, Equations as Relations, and in this lesson you learn to determine the range for a given domain and to graph the solution set for a given domain. Why is it important? Because you can use your equations to explore the relations in physical science and anatomy. And let's go to physical science. Are you as light as a feather or heavy as a rock? So the density of an object is the measure of its lightness or heaviness. Density is defined as the mass per unit of volume. Remember, we discussed this in science. The table shows the densities of some common substances. Air's density is 0.001 per gram per cubic centimeter. Aluminum 2.7 grams per cubic centimeter, and so on and so forth. You have water at 1 gram per cubic centimeter. Okay, gold has a very high density of 19.3 grams per cubic centimeter. So an equation relating the density, mass, and volume is equal to m equals dV, where m is the mass of a substance and d is the density, v is the volume. Okay, for example, the equation for gold is m equals 19.3 v, because the density of gold is 19.3 grams per cubic centimeter. This equation is called an equation in two variables, m and v. So when you talk about equation in two variables, obviously involves two unknowns and two variables. Okay. So FYI, if you haven't learned this already in science, water has a density of 1.0. Any substance with a density less than 1.0 will float in water. Any substance with a density greater than 1.0 will sink in water. And that's how objects float and sink. If it's more dense than water, it will sink. If it is less dense than water, then it will float. Okay? No one knows exactly when gold was first discovered. However, there have been gold artifacts dug up in Ur in Mesopotamia, in modern-day Iraq, that date as early as 3500 BC. Okay, suppose we wanted to know the mass of 4 gold artifacts with volumes of 10 cubic centimeters, 50 cubic centimeters, and 100 cubic centimeters, and 150 cubic centimeters. We can use a table to find ordered pairs Vm that satisfy the equation. So if we want to find if we want to know the mass of the gold, then we can use the formula m equals 19.3 v, okay, where v is given as the volume. These are your volumes, okay, and we can now create a relation or an ordered pair between volume and mass. So let's say the volume starts at 10 cubic centimeters, okay. Using the formula, this distance, density times volume, end up with 19.3 times 10. The mass would be 193. Therefore, our ordered pair would be 10 and 193. So for every 10 cubic centimeters, there is a volume of 190. Sorry, there is a mass of 193 grams. Okay. So again, if our volume is 50, you use the formula again. I will get a mass of 965. So our ordered pair would be 50 and 965, which means that for every 50 cubic centimeters, we will have 965 grams of gold. Okay, and we use 100, use the formula, end up with this with an ordered pair 100 and 1930 for every 100 cubic centimeters of for every volume of 100 cubic centimeters. Okay, the gram, the weight in gold or the mass in gold will be 1930. And finally 150, substitute that to the formula, end up with a mass of 2895. That's the ordered pair of 100 for every 150 cubic centimeters. Okay, the mass in gold would be 2895. Okay, and we can graph these ordered pairs. Okay, and the first quadrant, this is how you graph all the 4 ordered pairs. Since 4 ordered pairs are graphed at the right, okay, since each ordered pair satisfies the equation, each ordered pair is a solution of the equation. Okay, again, if these ordered pairs satisfy the equation, when we say satisfy the equation, That means if I substitute v and m to the equation m equals 19.3 right here. Okay, so m equals 19.3 times v. This is our equation. Okay, so if I substitute the values 10 and 193, v and m, to our equation, it will make the equation true. And that's what it means when it says it satisfies the equation. Therefore, each of these ordered pairs, all of them, are called solutions to our equation. Okay? So let's define a solution to equation. Definition of a solution to an equation in two variables: if the statement true results when the numbers in an ordered pair are substituted into an equation in two variables, then the ordered pair is a solution of that equation. Okay? Now, since the solutions of an equation in two variables are ordered pairs, such an equation describes a relation. Okay? So again, we talked about what a relation is. Okay? In an equation involving x and y, the set of x values is the domain of the relation, and the set corresponding y values is the range of the relation. Okay? Remember that I think that was way back in the last lesson, range and domain. So let's take a look at example 1, see how this works. Solve each equation for the given domain values, graph the solution set. And so when you say domain values, okay, so that means this corresponds to x, okay, x coordinate. Okay, so remember that. Let me take that out now. Okay, so make a table. The values of x come from the domain. Substitute each value of x into the equation to determine the corresponding values of y. So we get -3, -2, 0, 1, and 2. Put it in the domain right there. And then we substitute it to this particular expression 4x. So 4 times -3 will give us -12. 4 times -2 is -8. 4 times 0 obviously will be 0. 4 times 1 will give you 4, and 4 times 2 will give you 8. Now we can name the ordered pairs: 3 and -12, -2 and -8, 0, 0, 1, 4, and 2, 8. Okay? Now, and then we want to graph the solution set, and this is how our graph would look like. Okay? Let's take a look at example number 2. Y equals x plus 6 if the domain is -4, -3, -1, 2, and 4. Again, we make a table, find the values for y in the range by substituting the values of x from the domain into the equation. So we put all the values of -4, -3, -1, 2, and 4. And then we substitute the values, we end up with 2. So our ordered pair for -4 would be -4, 2. For -3, it would be -3, 3. If the domain is -1, okay, our ordered pair will be -5. If the domain is 2, our ordered pair would be 2 and 8. And if our domain is 4, our ordered pair would be 4 and 10. And if we graph that relation, this is how our graph would look like. Okay? Let's take a look at example number 2. It is often helpful to solve an equation for the y before substituting each domain into the value of the equation. This makes creating a table of values easier. Okay, so what does that mean? If we want to solve 8x plus 4y equals 24, if the domain is -2, 0, 5, and 8, okay, first and foremost, we need to first solve for the equation of y in terms of x. So when you say y in terms of x, that means you need to isolate y to one side of the equation. So let's do that. 8x plus 4y equals 24. We just copy the problem down. Since we want to find the value of y, we want to isolate y, okay, in terms of x. So we subtract 8x to both sides, end up with 4y equals 24 minus 8x. And then in order to isolate y further, we need to divide both sides by 4. You end up with y equals 6 minus 2x. And what you do after that you get 6 minus 2x, okay? And then put it in this part of our table. So substitute each value of x from the domain to determine the corresponding values of y in the range. So we simply put negative 2, 0, 5, and 8 to our x column right there. And instead of solving the equation every single time we find or we substitute the value of x, okay, we can now substitute it to this equation and we can find y a lot easier. So in this case, if x is equal to negative 2, we now have 6 minus 2 times negative 2, which will give us a value of 10, gives us an ordered pair of negative 2 and 10. If x were equal to 0, that would be 6 minus 2 times 0, or simply 6. Our ordered pair would be 0 and 6. If x is equal to 5, that would be 6 minus 2 times 5, or our value will be y, for y, will be negative 4. Our ordered pair would be 5, negative 4. If x is equal to 8, then that would be 6 minus 2 times 8, okay? And that would be, okay, and that would be negative 10. So it would be 8 and negative 10. Okay. After that, we simply graph our ordered pairs, and this is how it will look like. Okay. So you need to solve for y first in this particular example so that it's easier for you to create your table. Variables other than x and y are often used in equations representing real situations. Okay, the domain contains values represented by the independent variable. Graph the domain values on the horizontal axis. The range contains the corresponding values represented by the dependent variable determined by the given equation, and graph the range values on the vertical axis. So what this simply means is that when you're talking about real life situations, okay, you will have two variables, your independent variable and your dependent variable. And usually, not usually, every single time your independent variable is always graphed on the horizontal axis or your x-axis, and your dependent variable, so this is graphed on the x-axis, okay, and your dependent variable is always graphed on the y-axis. Okay, so independent is always on the x-axis, horizontal axis, and your dependent variable is always graphed on your vertical axis or your y-axis. And if you notice, okay, time is always when you're talking about a problem with time in it, it will always be in your independent variable because time will not depend on anything. Okay, so everything will depend on time, on the other hand, so time will always be independent. Okay, so when you solve an equation for a given variable, that variable becomes the dependent variable again. Okay, when you solve an equation for a given variable, that variable becomes your dependent variable. That is, its value depends upon the domain values chosen for the other variable. Okay. Take note of that so that you know what becomes dependent and independent when you're solving equations. Okay, let's take a look at example number 3 and let's apply what we know. The equation for the perimeter of a rectangle is 2w plus 2l equals p. Suppose the perimeter of the rectangle is 24 centimeters. Okay, so we know what the perimeter is, and what we want to do is we want to solve the equation for L. Remember, when you're solving for the variable, okay, the variable becomes a dependent variable, so when we're solving for L, our L becomes our dependent variable because it will depend on the input of our independent variable. So state the independent and dependent variables and determine the domain and range values for which this equation makes sense. Then choose 5 values for W and find the corresponding values for L. Okay, let's do this one at a time. Let's do letter A. What is letter A? It's saying solve for the equation for L. So we start off with, we substitute 24 in the perimeter of the equation and we solve for L. So we end up with 2w plus 2l equals p. and substituting the value, it will be 2w plus 2l equals 24. Again, we want to solve for L, and now we need to subtract 2w to both sides, so we end up with 2l equals 24 minus 2w, and divide both sides by 2, end up with the L equals 12 minus w. Okay, letter B, state the independent and dependent variable. Since we solve for L, this becomes our dependent variable. W becomes our independent variable. Since the value of L depends on the value of W, L is the dependent variable and W is the independent variable. Since the distance can only be positive, the values in the domain and range must both be greater than 0. Why is it only positive? Because there is no such thing as negative length. Okay? So that means this only should appear in the first quadrant if you are asked to plot this on a coordinate plane. Okay, so letter C. What is it asking letter C? Let's look at it again. Choose 5 values for W and find the corresponding values for L. So when choosing values for W, you can choose any number greater than 0. Again, it cannot be negative simply because there's no such thing as a negative length. Suppose we choose the domain 1, 2, 3, 4, 5, make a table of values. So since W is our independent variable, that becomes our domain 1, 2, 3, 4, 5 there, and we simply substitute W to our 12 minus W. Okay, 12 minus 1 will give us a length of 11. So if the length is 1, our W would be 11. Okay? If the length is 1, no, it goes the other way around because if this becomes our dependent variable, so this W, okay, so there's a little bit of a misprint here. So this should be a W and this should be an L right there. So if our width is 1, our length would be 11 because our length is dependent on our width. So let's cross that out so that there would be no misinformation. So 12 minus 2, your ordered pair would be 210. Okay, if your width is 3, okay, your length would be 9. If your width is 4, your length would be 8, and such the ordered pair for 8. And if your width is 5, your length would be 7. Therefore the ordered pair 5 and 7. Okay, so the solution set for the domain is 1, 11, 2, 10, 3, 9, 4, 8, and 5, 7. Okay, check to see if the solution satisfies the equation 2w plus 2l equals 24. Okay, and that's at the end of our lesson. Okay, thank you for watching.